My name is Uriel Cruz. I'm a computer engineering major, and I'll introduce my contribution, the voice-controlled boombox. So in my agenda here, I'm going to introduce some of the components that we have used and quickly go over minimized features to showcase our project. The computer we used in the beginning was the Raspberry Pi 4 with 2 gigabytes of memory. This was provided by Stakeholder to start off with the project, for which most part did the job. Though once everything seems in fully operating condition, which in this case it's almost done, we will intend to use a much faster Raspberry Pi, such as the Raspberry Pi 5 with 4 gigabytes of memory or more, to be more responsive. Since operating voice command takes a while for the system to keep up, taking sometimes such as half a minute. For the minimize features, this should all be done by giving a voice command such as playing music from the library, playing internet radio stations, playing music from the internet, and playing news from the news. Lastly, to perform basic player operations such as pause, play, stop, and etc. So our stakeholder recommends to use Linux as our operating system, and in this case we use Ubuntu Desktop. We want something that's easy for us to use while having a very simple operating system to minimize usage. Because of our Raspberry Pi 4 with limited to only 2 gigabytes of memory, we want something to have low usage. But even if we prepare everything was prepared by a stakeholder, all the files and the programs. But even if we follow their guidelines, it's not as simple as putting everything together and hoping. Some of the issues we encountered throughout the semester, in my case, no audio was playing after installation because everything has to be connected before turning on the device. So in this case, our our speakers weren't connected, or our microphone wasn't connected before booting up, causing it to misread which is input and which is output. But once everything is put together, it's fixed. Then, after everything was working as intended, we tried to install other software such as drivers for our touchscreen display, which caused it to have a problem booting up. And eventually we were able to fix that as well. And then lastly, as of recently, our voice controller software stopped working after reinstalling everything, but was fixed later on. There were many other issues that came up, but was either too minor to list or have been resolved. Some of the stuff we added was our hi-fi Barry DAC, which is to provide high quality audio to our speakers. Then we added some heat sinks to our Raspberry Pi, so since it's gonna be on for most of the time, it needs to stay cool as possible in this closed enclosure. And lastly, we have our touchscreen display, which will display our information to the user about the music that is playing. You want to move on to a faster device such as the Raspberry Pi 5 once everything is put together and we know it's working as intended. Then my job will be adding some new programs to make sure it runs reliably, and then debugging anything that arises from any of these files, which in this case can be very delicate. And that is all I have to say. Thank you.
Hello, my name is Brian Lopez. I am an electrical engineer working on the voice-controlled boombox. At the beginning of Senior Design 1, we met up with the stakeholder for the project. He provided us with a Raspberry Pi, two 50-watt speakers, a 100-watt subwoofer, and high-frequency tweeters, along with a 200-watt audio amplifier. The audio amplifier has a 6-channel output for left and right speakers, which connect to the mid-range and the tweeters, a subwoofer channel, and it also features Bluetooth connectivity and aux-in audio port. It also has audio controls for bass, treble, and volume. The Stakeholder also provided us with a power supply, which only has 21-volt output ports, which is fine for the audio amplifier, which works from 12 to 24 volts. But if you really want to make the device portable for the voice controlled, the Raspberry Pi needs 5 volts and a maximum of like 3 amps for it to run. So we're looking into different kinds of step-down voltage converters, and so far we got one, which is a buck style converter. The buck style converter steps down the voltage from 21 volts to 5 volts for the Raspberry Pi, but it also creates noise, which the Raspberry Pi picks up, which sends to the speakers, which is bad. That noise is caused by the switching action, which create ripples in the voltage and current. Ways to fix that is to implement filters, like an LC circuit filter in the input and output. Other ways is to also enclose the converter in a metal box, which helps with the radiated noise. We are also looking for a different kind of power supply that has around 20 volts output ports and 5 volt output ports to power both things. So far we've come a few of them, but they don't have a long amp power charge, so the play time will be like around 30 minutes maximum.
Hello, my name is David Lin, and I am a computer engineering major. I am currently working on a voice control boombox with 5 other engineers. I want to briefly talk about my contribution in Senior Design 1. After meeting with our stakeholder for this project, I went through the materials and information that were provided for us. As a computer engineering major, I was responsible for the software aspect of this project. This means going through the coding information on the GitHub that was made by the stakeholders. Since the choice of board was a Raspberry Pi 4, I looked into the Raspberry Pi to get familiar with it. Not only that, since the operating system is in Linux and Python is being used, I also did some research on them. My main focus this semester was the LCD display. The LCD that we went with is a 4-inch IPS touchscreen display by Maclsaac. Before working with the LCD board, I looked into the specification and the manual of the LCD board. As you can see in the picture, the display is connected to the Raspberry Pi 4. I was able to make a basic graphical user interface, other known as GUI, that displays basic things like the name of the song and the pause button and the play button. My future plans going into next semester is that I want to make a more advanced GUI music player, kind of similar to Spotify. I want to work more on the back end to link the GUI to the directory of where the music is coming from, whether it's from the internet or through radio. I also want to add responsiveness to the GUI to allow touchscreen features.
Hello, I'm Corey Barber. I'm an electrical engineer working on the voice control boombox project for Senior Design 1. At the beginning of the semester, I helped with checking all the components that our stakeholders provided with us. This involved checking to make sure none of the speakers were broken during transportation, and then making sure the amplifier worked. Another way we did this was we hooked everything up together and we played music through it. I also looked up the specifications of the speakers so that we knew the frequency responses of each, along with power rating and the impedance. I also helped with the troubleshooting of the microphones and the voice recognition. This included checking to make sure that when we said things, it translated in a timely manner and that it translated it accurately. And then following up with that, I helped out with figuring out where the command for playing music, specifically from the radio, went to. So I looked through PuTTY records and found out where it was getting the link for those commands. Because we want to make this design portable, we wanted to use batteries to help charge and run the speaker from. And in order to know how long the speaker could last for, I did a rough calculation, so we had a estimation for a start. So I did that by finding the total watts of the speakers, which I used from the specifications I found earlier in the semester, and then found the watt hours the batteries had. And I found out for the speakers running at like their average everyday use, it would run for roughly 4.5 hours, as this theoretical calculation shows, and that the speakers at maximum volume will last for just under 3 hours. Going forward, we are going to run more tests and actually get a more measured number for these. This is just a starting point so that we have numbers to base the actual measurements off of. Recently, we've noticed some static that's been playing through the speakers. So when there's no music being playing through, we hear some static. And we've been starting to brainstorm ideas and make some changes to try and eliminate the static noise. One of which is we have upped the gauge of our wires connecting the speakers from 22 gauge to 16 gauge, hoping that will give a more clear sound and eliminate the static. We've also started looking into ways to filter out the noise by using filters. We've also looked into changing the batteries to see if that's going to give us a more clear power signal.
My name is Oliver Trzcinski, and I am a junior mechanical engineering major. I'm working on the mechanics aspect of the voice-controlled boombox. The enclosure itself comprises most of my concern with the project. The subwoofer enclosure of a boombox needs to be a specific volume in order to have maximal sound, power, and quality. This is due to the amount of air within the sealed environment, which allows sound to optimally resonate the air within it. However, there is a limited amount of space available in the boombox. Constraining the size of the boombox allows it to fall under the category of a boombox, since you can carry it while maintaining sound quality. The subwoofer needs to be 0.13 cubic feet. However, the quality of sound of the mid-range and tweeters also are dictated by the size of their enclosure. To mitigate this, a port is installed on the left and right side of the boombox. The value of 0.13 feet cubed was chosen since the Stakeholder found the cleanest sound quality with it. Internet searches and other research provided various values with various shapes, but the Stakeholder tested and believes this is the best volume. There will be design iterations specifically made to test the best quality of subwoofer enclosure. Subwoofers can be sealed or unsealed. A sealed subwoofer uses the air's resonance, while an unsealed subwoofer amplifies the sound of its surrounding by pushing the air in front of it. We are going to use caulk for the initial prototype to seal the subwoofer. Later iterations will likely use wood glue and Dota joints. Working with other engineers, the concerns of storage are a top priority. We need to hide the Raspberry Pi, an amplifier, microphone, batteries, and cables within the boombox. Nothing can be sticking out. The speakers also need to be powered. So prior to sealing the boombox, there will be wire installations to power the speakers and deliver the sound to them. And they will also be sealed for the subwoofer enclosure. The largest issue with batteries is the ratio of power and heat. I focused on the latter and found that there are solutions to the heat. The most effective, and it happens to be the simplest, is to put the battery off to the sides. The Raspberry Pi, which also has heat concerns, you would put on one side or the other, and the battery and Raspberry Pi would be as far away from each other as possible. You might be interested in the material we are using. We are currently using plywood from Lowe's since it is cheap and easy to work with. Being less than $30, it allows us to quickly make a prototype and not worry about screwing up the wood itself. The final product will likely use Baltic birch, which is much heavier, much denser, and produces a much better sound quality than plywood. This is the stakeholder's choice and has high quality of sound than most other woods he has tested. We have also considered 3D printing it. However, the subwoofer enclosure causes too much deflection, which would cause the 3D printed material to break. We've considered doing it out of metal, but metal also resonates and vibrates much more easily than wood does. Yeah.
Our design was a voice-controlled boombox. I'm going to go through intro, approach, progress, aesthetics, design, and next steps. So we did a lot of research into improving the boombox, and we had to select materials that would work. We originally, the stakeholder used wood, but we couldn't use wood because of the price of it, so we ended up with plywood, and we also needed to print out certain 3D models, so we were looking into materials that would work for that. However, when we're done building the enclosure, that's when we'll go more into the 3D materials. And then our design, we decided to add design features such as a screen that turned out to be a little bit more difficult than we thought. So the install, we're still going into the install. We're making enclosures. We've already made a prototype, but now we're trying to make the final enclosure that we can use for our final project. Our approach is finding the best and most efficient way to design the voice control boombox. And by saying this, we really just want a boombox that works and works well. It goes from 200 hertz to about 20 kilohertz, which is proving a bit difficult because we're having some problems with the amplifier sometimes when it turns to a certain volume. But we've also somewhat fixed this because some of the connections were loose, and we've done this by getting better connections. And when our enclosure is done, we're gonna heat wrap it and solder the remaining areas. So our major issues with the project as of right now that we're trying to sort out is when the Raspberry Pi is connected to the amplifier, our screen is working because of the connections we made with SPI. However, when the amplifier is connected to Bluetooth, our screen on the boombox is not working, but we decided we didn't need that as a design feature after a lot of research because we already had a screen on the phone, so they wouldn't need that. And it proved harder than we thought just because we tried to get the amplifier to connect to both the phone and to the screen and vice versa. So everything we wanted to connect at the same time. And with the phone, you can connect to 2 different Bluetooths at the same time. However, the screen, we had a harder time, and we'd have to use HDMI to Bluetooth, and we'd need 1 HDMI to 2, which was a lot more expensive than we had originally thought. So that was a restriction that we couldn't really pass. So we decided just to leave it at that as of now and try and find better options later. So our next steps was just to continue to build the enclosure. That's the main thing right now. And then to make the connections inside the enclosure and accept certain design flaws due to our restrictions. We do have a lot of restrictions just because we were given the model that we're supposed to create for the most part, and it's just us building it and fixing some of the code that had issues with it. And our total cost right now is $60 because our stakeholder has given us, as we said, most of the components. He has not given us the wood though, or the batteries, so we did order the batteries. Thank you.